Hi, my name is Riley McAteer, and today's date is May 15th, 2026. Today, I will be giving my explanation of my assigned spectra problem, which is P group 5, as shown on my printed piece of paper. So my molecular formula is C6H12O2. So my first task was to find the degree of unsaturation, or the DU, and I would do this by using the classic formula, which would be 2 times C, which is the amount of carbons. In my case, it would be 6, plus 2, and then minus H, which is the amount of hydrogens, which in my case would be 12. And then after calculating that, I would divide it all by 2. So my degree of unsaturation is 1, so I had 1 site of unsaturation, and this would indicate, and I would expect actually, that I would have either a ring or a double bond, most likely a carbonyl, since we do have an oxygen present. And next, I will be showing my IR table below. So this is my IR table. At about 1735, there is a strong ester stretch, so a carbon double bonded to an oxygen stretch. And this confirms a carbonyl, not an alkene. And then at about 1200 to 1100, there's a strong carbon single bonded to an oxygen stretch of ester. And so this is supporting an ester, not a ketone or an aldehyde. At about 2950 to 2850, we have sp3c carbon bonded to hydrogen stretches. So this shows that alkyl groups are present. My IR table strongly supports the presence of an ester, and also there is no broad oxygen single bonded to hydrogen stretches, so this would then indicate that there is no alcohol or acid present. So next I will show my 13C table. So for C6H12O2, an ester with no aromatic, I would expect, so we see that the most downfield carbonyl is at about 173. And this is clearly an ester with a carbon double bonded to an oxygen. The 60 signals an oxygen single bonded to a CH2, which fits an ethyl ester. Next is the 30 to 40 carbon, which is alpha to the carbonyl. And the upfield signals around 14 to 22 here are simple alkyl groups, so CH2 and CH3. And the carbonyl is the most deshielded as a result of its strong polarity and anisotropy. Next, I will be describing my 1H NMR table. So this spectrum shows a total of 5 signals with integrals. So we have a 3H, another 3H, and then a 2H, and a final 2H. And this would add up to 12 H's or 12 hydrogens, which matches an ester with 2 CH3s and 3 CH2 groups. And this is a classic layout of ethyl butanoate, which the structure, which I have right now here, would be CH3, CH2, CH2, carbon, double bonded to an oxygen, and then single bonded to another oxygen, and then from there a CH2, CH3, as I have here. So looking back at my 1H NMR table, you see that there is a 2H quartet at about 4.1, which tells me I have an oxygen CH2, CH3 fragment. Then I have a triplet, or a 3H triplet, at 1.3, which shows a CH3 next to a CH2 in the ethyl group. And next to this is the 3H triplet at 0.9, which shows the terminal CH3 in the butyl chain. And lastly, I wanted to go back and point out the 2H triplet that is at about 2.3, and this is a CH2 next to the carbonyl. So putting all this information together from my 1H NMR table with the formula C6H12O2 and a DU of 1, the only structure that fits this would in fact be ethyl butanoate. So that is my final structure, which I will show you here more closely. I have it drawn here, and then I also wrote out its molecular formula below. It matches my provided molecular formula. Excuse me, this isn't the molecular formula, it's all the atoms just written out together. But it matches my molecular formula. It also has a DU of 1, which I calculated in the beginning. It matches my ester IR peaks, and with my 13C NMR table, it shows the pattern including an ester carbonyl and also an oxygen bonded to a CH2. And looking at my 1H NMR table, ethyl butanoate also matches 2 CH3 groups and 3 CH2 groups. So this is one final look at my paper. Thank you so much for your time.